Let's begin. Today's May 16th, 2024, and we're doing the Daily Turing Machine Puzzle. So today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's visit turingmachine.info for the details. So today's puzzle uses criteria cards 6, 8, 16, 19, 21, and uses the blue verification cards. And above we have our unique identifier for this puzzle. Let's go solve. So in our grid above, we've got our 5 criteria cards. The top row has criteria cards A, B, C. And in the bottom row, we've got criteria card D and E. So criteria card A will let us know whether the middle digit, the square digit, has an even or an odd value. Criteria B will let us know the quantity of 1 digits in our solution. Are there no ones? Is there a single one? Perhaps there are 2, maybe even 3. Criteria C will let us know the number of even versus the number of odds. Should there be more even than odds or less even than odds? Criteria D will take the sum of the first 2 digits, triangle and square, and we'll compare that sum to the number 6. So should the sum be less than 6, equal to 6, or should the sum be greater than 6? And finally, criteria E will let us know if there is a digit that repeats, meaning that there's a pair in our solution, as in the example 131, or on the flip side, there is no pair, which would mean that the solution either has all unique digits, as in the example 134, or has a single digit repeated 3 times, as in the example 222. Remember, our objective is to find that one unique code that meets all of the criteria that we've discussed. And today, our first proposal is the code 314. Okay, so I'm going to start off by testing criteria A to determine whether the middle digit is odd or even. So the Turing machine responds correct. It approves of my square digit. So again, if I look at my proposal 314, that middle digit is odd. The Turing machine approves of that. So that means I'm going to write down in my notes that the square digit should be odd. So square is odd. Okay? And so what I'm going to do above is I'm going to cross out all of the even digits. So it can't be 2 and it can't be 4. Okay. Next, I believe I'm going to test criteria C. That'll let us know if there are more even than odds. So criteria C. So the Turing machine responds, no, it is incorrect based on my proposal of 314. Notice that I do have 2 odds to my 1 even. Turing machine does not approve of that. So therefore, that means that in my notes for criteria C, I'm going to say, well, there should be more even than odds. Okay? So what does that mean? Well, if my middle digit is odd, that means that triangle and circle must be even. So that means I can cross out all of the odds for triangle and do the same for circle. So neither of those can have odd digits. Okay, so this gives us a general idea that our final solution should be an even followed by an odd and then finally end with an even. Okay, so criteria B, we could test whether that odd in the middle for square, is it a 1? Obviously there can't be 3 1s because, well, we got 2 evens. And for the same reason, there can't be two. So it's either it exists or it doesn't. So if we test that and it's correct, then fantastic, I do have a 1. But if it's not, then all I do was eliminate it. I would still have to test whether it should be a 3 or a 5 in a later turn. I could check the sum, but I think what I'll do is I'll test criteria E. Since I do have 2 evens, I want to find out, hey, are the evens duplicated? Are they paired up or not? So let's take a look at criteria E. Okay, so the Turing Machine approves of my proposal. So notice that in my proposal, I don't have a pair. So it approves that there shouldn't be a pair. So that means that it approves the fact that they are all unique. So I'm going to state for criteria E that all digits are unique. All digits are unique. Okay, which means that, yeah, the evens aren't paired up. So that means that our code should have a 2, a 4, and an odd. But of course, we still don't know whether the 2 goes for the triangle or does it go for the circle, and vice versa. So we still don't know that. Okay, so we're done with this proposal. We've already asked our 3 Turing tests. So now we need to come up with our next proposal for the second round. So let's see. We didn't check the whether there is a 1 or not, and we also didn't check what the sum is. Okay, so the good thing about we know that there's a 2 and a 4 is that, if we kind of count how many potential solutions there are, well, there are 2 values for triangle, and then there's 3 for square. Actually, we don't have to count up the circle, because if triangle is 2, circle defaults to 4. Or if triangle were 4, circle defaults to 2. So it's as if we don't even have a choice. So at this point, that means that we have 2 times 3, or 6 possible answers. So let's think about this before. If I were to choose the 1, right, because we do have that criteria B, what would that look like? That means that it's either 214 or 412, right? If I choose 2 here, and I'm anticipating maybe there'd be a 1, so it would go in the square, so it'd be 214 and then 412. If that is the case, how would I distinguish between these 2 codes? So they both have an odd, right? An odd 1. Okay, so these 2 would be correct. They both have 2 evens, which is and 2 and 4, mixed in there. Let's look at their sum. So 2 plus 1 is 3, and 4 plus 1 is 5. Both of those would be less than 6. And of course, there is no pair, no duplicate. So there's no way to distinguish between these 2 codes based on the criteria cards that we've been given. So that's what I call, I don't know what the Turing Machine community, board game community calls this, but I would call these ambiguous, because there's no way to distinguish them. Again, here I am assuming that it's 1. I haven't tested it, but if I were to say, you know, again, as a thought experiment, pretending that it's a one, what would happen? So it would only generate these two possibilities, and I don't see a way to distinguish them. They all would meet the criteria. So I think we can eliminate these possibilities. Okay, so that means that it can't be a 1. Square cannot be a 1. And so I'm going to write down in my notes for criteria B, since I really didn't test it, that I'm going to deduce there is no single one digit. So that would leave potential solutions to be 3 and 5 for square. Okay. So that then leads us to just 4 possibilities. So let's go up here and see what they look like. So that means it could be either 2, 3, 4, or 2, 3, 5, or 4, 3, 2, or 4, 3, 5. Let's see if I got that. 2, 3, 4, 2, 3. Ooh, sorry. This should be a 4. So 2, 3, 4. Oh, I duplicated. Oops. Let's see. So it should be 2, 3, 4, or 4, 3, 2. Sorry, this should be 4. Oh, there's my 4, 3, 2. Okay, well, let's just keep it there. And so I cross these. So then it'd be 2, 5, 2, 5, 4, or 4, 5, 2. Okay, let me double check because I don't want to make a mistake. So 2, 3, 4, and or 4, 3, 2. So it's using the 3 and I'm just flipping the 2s and 4s. And same thing here, I'm going to choose 5 in the middle and then flip the 2 and the 4. Okay, yeah. Okay, so now if we look at that, that would mean, again, I deduce that there is no single one digit. So far they have, an odd in the middle. Don't know which one it is. It's not a 1. There are more evens than odds. And there is no pair. Nothing is duplicated. So the only thing to distinguish all of these is the sum. So the first one has a sum of 5. 4, 3, 2 has a sum of 7. 2 and 5 has a sum of 7. And 4 and 5 have a sum of 9. So these last 3, I believe, would also be ambiguous. Because if I were to say, hey, let's pretend the sum is greater than 6, all the last 3 would not only meet criteria D, but all of the other ones as well. I believe these last ones are also ambiguous. So I want to cross them out. There's no way to distinguish them. For the same reason that these ones below also failed. Can that be? We had 3 tests and that's our solution? Well, let me say D again. I'm going to deduce that the sum of triangle plus square is less than 6. Now, what I haven't said is eliminated equal to 6, but that's easy because the top row or the triangle has evens and the middle digit, the square, has odd. So whenever you add an even and an odd, it's always odd. So I think automatically we know it's not equal to 6. but these other ones were eliminated because there's no way to distinguish between these last three possible solutions. That's amazing. 5 are ambiguous. Okay. Well, I'm hoping that my deductions turn out to be accurate. So that means I am stating that 2, 3, 4 is the only unique code. Okay. So yeah, the sum, I deduce that the sum is less than 6. Okay. Well, let's go test it out. So let's go to turingmachine.info, test the code, and again, that was 234. Yes. 234. 234. And verify. Wow, okay, so it was correct. Okay, well, let's see. I mean, three Turing tests was pretty low, and we only tested ACE, 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 and I believe the middle one was incorrect. Yes. Okay, well, let's see what the Turing machine says. Wow. This is pretty unprecedented as far as this YouTube channel, that we answered it in one round 3 questions, and the Turing machine took 6 questions. Okay. Well, I will say that these thought experiments of not necessarily trial and error, but experimenting what if is powerful. I just yeah, I don't know what else to say, but we did beat it. So it was a great it was an interesting puzzle, to say the least, since we ended up with 5 ambiguous solutions due to 2 different criteria. We'll just take the win. So please leave a comment if you're an avid Turing Machine board game player. Have you seen this before? What are your thoughts? Is the logic sound? Any comments would be appreciated. If you did like this video, please give it a thumbs up so that others can become aware of the channel. And if you want to be notified, please subscribe, and you'll find out when the next video becomes available. Well, thank you so much. Have a great one.